Okay, so we're starting our new unit, which is about linear systems. So we're still dealing with equations of a line. So we're still dealing with y equals mx plus b. But we're talking about two lines right now. Okay, so we have two lines. We're gonna have to find out where do they meet. Okay, so when they meet, that's when they're equal to each other. Okay, so if I'm walking, let's say from here to Costco, okay, and someone else is walking from the lake to Sobeys, okay, somehow, somewhere, because we're walking on lines, we're gonna meet. Where are we meeting? Okay, on our trip. Okay, where are we meeting? Okay, so basically this is what we're looking as well when we're talking about solving a linear system. Okay, so when we're talking about solving a linear system, that means we're looking at when do these 2 points meet, when are they equal to each other. Okay, so the first part that we look at is graphically. Okay, so looking at a graph and then pointing out where do these two lines meet. Okay, so they're going to meet at a point, right? So the point is x and y value. Right? So if you're looking at the first graph, where do the two lines meet at what point? 2 and 2. Right? So they meet right here, which is, if you're looking at the x value is 2, and the y value is 2. So the point is 2, 2. Okay? We call this point of intersection. Okay? Or it's also called a solution, right? Or it's called a point of intersection. You'll hear me saying POI, POI, which is point of intersection.
Yes, POI.
Okay? Instead of writing point of intersection every single time, I'll say POI.
Abbreviation.
Okay. Yeah, abbreviation. Okay? Now, when the question is asking you to state the solution, it's asking you for the POI. Okay? Now, where's the POI of the second?
Here, at 5 positive.
5, so right here.
And 4 negative. Y.
So the x is 5, and the y is negative 4. So the point is in bracket. 5 goes first because it's x, and then negative 4. Okay, where would be your POI for the second one? Third one, I mean?
What's the 1 point there? Then we have to come -3.
Positive 5.
-3.
Minus 3.
Positive 5.
Positive. Right? X first, then y. So it's negative 3, 5. Okay? Now this is easy because the graphs are already drawn for you. Right? Now when you have to draw, this is where it becomes not hard, it's just you have to plot properly. Right? If you don't graph properly, that means you're gonna get the wrong answer.
We are revising. We are revising.
Yes,
Revising.
yeah, it's yeah, we've done this before. We've done the
already
graph.
done it.
Yep. Okay, so solve the following linear system. Both the Girl Guide and Boy Scout are hiking through Algonquin Park. The Girl Guides are traveling in a direction that is represented by the equation y equals 2x plus 3. The Boy Scouts are traveling in a direction that is represented by the equation y equals negative x minus 3. Find the coordinates of the point where their path will cross.
Yes, POI.
Okay, so find the POI. First, we're going to have to graph. You guys remember how to graph lines?
Yes. Intercept, y-intercept, first of all.
So let's look at the first equation. Where's my y-intercept for the first equation? Where's my y-intercept?
Positive 3.
Positive 3. What's my slope?
2.
2. That means I have to go up 2 over 1. Up 2 over 1. If you don't know how to graph, you're going to find it very hard in this unit.
Yes.
Okay? So, my y-intercept, I locate that. So it's at plus 3. And I have to go up 2.
5.
So 1, 2, over 1. Now, because I can't fit another point up there, so I can go down 2 over to the left one. Okay? So I can go right here. So I can now kind of graph the okay? Extend it, make sure you extend it, because sometimes you have to extend in order to find that point of intersection. Okay? So that's my first graph, which is the girl, right? Okay? Now we're gonna move to the boys scout. What's my y-intercept?
Minus 3.
Negative 3, so I have to locate that. So it's right here. And what's happening to the slope?
Minus 1.
So it's negative 1. So where do I go?
Down.
Down 1 over 1.
Look at 4. Minus 4.
So down 1 over 1. Down 1 over 1.
Yes.
Right? I can extend it a little bit, and then I can go, if I want to go up 1, then I have to go to the left 1. Right?
Yes.
You see, I found my point
Now
of
it's more
intersection.
clear.
Yeah.
Yes. Yes.
Is the point of intersection -2 and -1?
Negative 2, negative 1, that's correct.
Yes. Yes.
Okay?
Yes.
So the point of intersection, if you look right here, it's at this point,
Yes.
which is negative 2, negative
Negative 1.
right? So the POI Are we okay with this?
Yeah.
Excellent. Okay. Is that your next? Okay. When I say a linear system, I'm talking about two lines, equations of two lines, because now it's a system. It's not one thing only, it's two things combined together. Okay? So a linear system is represented by equations by two equations of or two lines or lines. The point of intersection, or we call it POI, of the two lines is the solution of the linear system. Okay? So that POI is my solution, is my answer to the question, is when the two lines meet. The POI coordinates being the x and y, right? Will make each equation true. When x and y values are substituted into each equation. Let me tell you what this means. Do you guys remember, can you guys tell me what the two equations that we had in the previous question? Y equals 2x
2x plus 3.
and
The next one was y equals negative x negative 3.
and then what was my POI?
The POI was negative 2 and negative 1.
Good. So, if I take that POI and plug the x and y into my equation, into this one, and then I plug it also into this one, both of them are going to be true. So that means the left side is going to equal to the right side for both equations. Okay, so let's check that. So if I take that x and y, plug it into the first equation, so replace y with negative 1, replace x with negative 2. So I'm going to get negative 1 equals to negative 4 plus 3. Negative 1 equals to negative 1. Right? So my left side is equal to my right side for the first equation. So it's true. Check. Right? So that's a check mark. Now I'm going to have to do the same thing, plug it into the second equation, so into this equation. Okay? So I'm going to plug in negative 1 for y, and then I'm going to plug in negative 2 for x. So negative 1 equals to 2 minus 3. 2 minus 3 is negative 1. So, you see that POI, if it's wrong, if it's not right, it won't work.
Yes.
Okay? So, this is what it says right here. So, the POI coordinates will make each equation true when you plug in the x and y into the equation. Do you guys understand that?
No, you're just checking your work.
You're checking if that's correct.
Yeah.
And for it to be correct, both equations have to be true. Okay? Both have to check. Okay, we just did that. So you can check to see if the solution is correct by substituting the solution back into your equations to see.
Can we write plug in?
Sure. To see if the left side of the equation equals the right side. I think I'm missing an S. Subs. I'm missing an S.
Substitute.
Okay, now, eyes on me first. You see how in the previous page we said that we looked at the graph was given to us, we looked at the graph and we said the 2 points intersect, or the 2 lines intersect at this point, right?
Yeah.
So this is one way of finding the solution, is by graphing. You graph the 2 lines, you locate the point of intersection. Okay, that's one way. There's actually 3 ways that you can solve for a system, linear system. First one is graphing, okay? The second one is called substitution. And the third one is called elimination. We're gonna learn all 3 of them through this unit.
Elimination.
Okay?
Elimination.
Elimination.
Elimination is one of them.
Going somewhere else.
What does the word elimination mean?
Eliminate somebody from the scene.
Deleting, right? Getting rid of something. I'll show you something. Substitution, I'm gonna say. When you're looking at the system right here, right? If you look at these 2 equations, you have y and you have x, right? With the elimination, you eliminate one of the letters. And you eliminate, that means you make one of the letters equal to 0. We're gonna learn about this, okay? And then the substituting is you're gonna take one of the equation and then you're gonna plug it into the other. Okay? We're gonna learn about that.
Is
next.
this another way to check it?
Third way,
No, this is one way to solve your work,
Oh.
not to check it. Okay? It's solving. So to solve for your point of intersection, if you don't want to graph,
Oh,
you
No.
use substitution or elimination. Okay?
I like it the regular way.
Well, they're all regular ways. Graphing is one of the ways, but sometimes we have to do algebraic, because sometimes when
But
you're
it's
graphing,
nicer to be able to see it though.
yes, but what if the point fell in between the lines? How would you be accurate?
Well, if it was a
What if-
decimal, then yeah.
What if my point of right here? Right? Do you know what this point is? 100%.
No.
You
But
can
then
estimate.
In that situation, then I would use the other one.
Yes. Right? So you have to learn how to use the different ones. Now, substitution and elimination, you get to pick which one to use, but at the same time, sometimes it's easier to use substitution, while other times it's easier to use elimination. We're going to talk about the different cases. One is easier to use this one is easier. If you ask me, I would always pick elimination, because I like the elimination method.
I
Because
also
it's
like to
easier.
learn. I could not learn when I was in grade 9 and 10. Elimination.
Now you're gonna learn it. Okay, so we're gonna learn today how to solve by graphing. Okay, and then later on, maybe not tomorrow, maybe the day after tomorrow, we're gonna learn how to do. Maybe Thursday we're gonna learn how to do by substitution. Okay? So remember that when we're graphing, we learned how to graph using the y equals mx plus b method, right? The slope and y-intercept, right? Is this in the form of y equal mx plus b? No.
No.
Right? Remember, y equals mx plus b, y has to be by itself, everything else should be on the other side.
Yes.
Okay? So if it's in this scenario, you have to do the work a little bit
Oh.
first
Yes.
and then graph. So to do the work, that means I have to rearrange, right? So I want y by itself, I have to move x over. What does it become when I move it over?
Minus X
Negative x.
plus
plus
6.
6.
No, same thing.
Mm-hmm.
Same thing.
Do you guys understand that?
Yes.
Yeah.
So is this now in the form of y equals mx plus b?
Yes.
Yes. What's my slope?
Minus 1.
Negative 1. What's my y-intercept?
6.
6.
Plus 6.
Good. Let's rearrange this one as well. How would I rearrange this?
Bring the 2 over, it becomes a negative.
Bring the 2x.
2x over, sorry.
So I would have negative y equals negative 2x, right? Yeah?
Yeah.
How am I done?
No.
No, why not?
It's the negative.
Minus 6 can be 0
Uh-huh.
plus 0.
I didn't even.
You don't have to include that 0, right?
Okay.
Plus 0 or no, it doesn't matter.
Okay, okay, understood. Understood.
Okay. Scott, what were you saying?
Because the negative in front of the y.
There is a negative in
So-
front of the y. I can't have a negative in front of the y.
You can,
So you put it over,
divide by minus 1.
becomes a positive. But
When
then you
you-
have to put it and divide it.
You have to divide, but you divide by negative. To
But
get
you-
rid of it,
but-
you have,
Oh, okay.
the only time you change the sign is if you're moving it as a plus or minus.
Okay.
When you're dividing, you divide by the exact same value. You don't change the sign of that. Okay? So because this is a negative 1 here, right? So I want to get rid of it, so I divide by negative 1 both sides, right? To eliminate it, right?
Y is
Okay.
equal to 2x.
So that would be y equals
2x.
2x. Okay? It's very important that y has to be by itself, no negative in front of it, no number, no nothing.
Would that mean that the slope is 0? mean, the y-intercept is 0.
That's right. The y-intercept is 0, the slope is
2.
2. Right? So you don't need to write that, but this is just so you guys see. Okay, let's graph the first one. Where do I start? First one, this one. Y equals negative x plus
Positive
6.
6.
6,
Positive
plot
six.
about 6.
Okay, I think positive 6 is right here. And what do I do?
Then come down 1.
Come down 1 over
1.
1.
1. Down 1 over 1. Right, you can keep going if you want, as long as you want. Okay, so this is the first equation. So this is this. I'm gonna go with red for the second equation. So where do I start for the second equation? Where's my y-intercept?
0.
0.
Stay the 0.
At the origin, right?
And go to up
How much do I go up?
2.
2. I go up 2 over
20.
1. Over 1.
Yes.
Up 2 over 1. You see the point of intersection?
Oh, we already got it.
Yeah, I know, right there.
There, okay.
Okay? So my point of intersection is
2 and 4.
2,
4.
4. 2
4.
is first.
POI 2.
So it is 2. So here is 4. It's all complete.
Okay? Now for the checking, you have to plug in your POI.
Yes.
You have to plug in the POI into both equations. It doesn't matter if you use the original one
Yes.
or if you use this one, right? They would both have to should work. Okay? I'm gonna plug it into the original one just because this is safer. This will tell you exactly if your answer is correct or wrong. Okay? So I'm gonna plug it into the original one. So I'm gonna plug in 2 for x, 4 for y. Oops. 2 plus 4 is 6, right? So left side equals,
Right, right.
so that's for the first equation. And for the second equation, I'm gonna plug in 2 for x, 4 for y. 2 times 2 is 4. 4 take away 4 is 0. Left side equals right side. So I check.
Are you going to be asking us to check it on the test?
Yeah.
Yeah.
Could be.
Okay.
Right? Checking is the way to know if your answer is correct or wrong.
Oh, of course.
Okay? Checking is more for your benefit
Yeah.
than for
You
mine.
got the mark.
Right?